ladies and gents. We are continuing with parallelograms and we are proving theorems. This is the first time really that you learn how to prove a theorem. Now in our last lesson, we proved that if we have a parallelogram, what is a parallelogram? Just to remind us, and we've got two pair of lines that are parallel to each other. So AD parallel to BC and AB parallel to DC. So our first theorem, it was kind of a double theorem. We proved that if we have a parallelogram, that means that AB equals CD and AB equal BC, opposite sides equal in parallelogram. And at the same time, we proved that angle A is equal to angle C and angle B equal to angle D. So opposite angles are equal. Okay? What we're going to prove now, that's theorem 2. We're going to put theorem 2 and 3 in the same video, hopefully. Theorem 2, okay? Theorem 2, I'll call it T2. We need to prove that diagonals bisect each other. Bisect, you remember, means halve. Okay? In other words, we need to prove, okay? We need to prove that AE equal to EC, AE equal to EC, and BE equal ED. That's what we want to prove. Okay? Now, the idea of the proof is the same as the idea of the proof we did last lesson. It's all about congruency of triangles. Congruency of triangles. Okay? Now, what do we know already? Okay, which triangles are we going to look at? These ones. We're going to prove the congruency of these triangles. If these two triangles are congruent, then that side equal to that side, and that side equal to that side, because, you know, sides are congruent triangles. So, how are we going to prove that they're equal? What do we know about these two triangles? Just pause here for a second. Okay, so guys here, obviously, they realize. So we have two sides that are equal. Okay, we're looking at these two triangles, right? So we know that AB equal to CD. Remember, we have to give a reason for every statement. And the reason here is opposite side equal in parallelogram part. Okay? So that's one pair of sides are equal. Now, another angle they equal, okay, we'll call this 1, this one 2, 1, this one 2. Okay, so A1 equal to C1, okay, alternating angles equal. And we need to mention also which pair of sides are parallel here. AB parallel to CD. And then we've got another pair of angles that are equal. Okay, we can call that 1 and that 2. So E1 equal to E2, because these are vertically opposite angles which are equal. Okay, there's another pair of angles that are equal, those two. Okay? Again, because they are alternating. Okay? But I only need two angles. Okay? So at this point, I can say the triangle AEB is congruent. Okay? Congruent. And here I have to be careful with the letters. Okay? Because I said A, start with A, and angle A is equal to angle C, so I need to start with angle C. Okay? So C, E, D. Okay? A, E, B, C, E, D. Okay? If you line up, this is a good trick to know. If I take all the angles from the left triangle on the left side, A, E, and all the angles of the right triangle on the right, CE, that will help me write down the name of the triangle. Can you see it? Okay? So it's AE, and the last one is B. So the triangle that I have to write here is CE, the last one is D. Does that make sense? Okay? Right. And I need to give the reason is AA. Now, why am I doing this? When I know that these two triangles are congruent, then I can say the following. I can say BE equal to ED, okay? BE equal to ED. And I can also say that AE equal to EC, and I need to give a reason for both of them, okay? Sides sides in, I don't even need to write it. All I need to do is just repeat the congruency. Okay? Why are these sides are equal? I just need to say because triangle A, E, D is congruent to triangle C, E, D. Okay? That's for both of them. Okay? I'll pause here. Chaps, theorem 3, the third theorem we're going to prove is a way of proving that this is a parallelogram. Okay? So I know that if I have two pairs of lines that are parallel to each other, it's a parallelogram. Okay? I also know there was a theorem saying that if both pairs of lines are equal to each other, it's a parallelogram. Also, we have another one that if the opposite angles, both opposite angles are equal to each other, it's a parallelogram. But the last one, if you remember, was a little bit different. Okay? If I know that just two lines are equal to each other and parallel to each other, I know nothing about these, it's also a parallelogram. So I need to prove that. Okay? I need to prove that these two lines are parallel. Well, that's a parallel. Okay? Right. What I'm going to do, okay, I'm going to draw a line here. I'm going to draw a diagonal. And again, I'm going to prove congruency. Okay? I'm going to prove congruency. Okay? Now, I've got one side in those two triangles that I know already is equal. Which side is that? AD and BC. I know that this is equal to that because that was given. Okay? So, all right, AD equal BC given. Yes, Oli?
What is the shared line?
The shared line, yes, you did say AC. So AC obviously is equal to itself. We say common side. Fantastic. So I'm looking for an angle. They're alternating angles, isn't it? Okay? We'll call that A1, 2, 1, 2. Okay? So I'll put these ones. Okay? Right? So angle A1 equal to angle C2. Alternating angles equal, and I need to write the lines that are parallel, ADBC. Okay? So these two angles are equal. In this case, I can already I can say that they're congruent. Okay? So I'm going to write this triangle on the left one here. Okay? So I'm going to start with A, B, C. Triangle A, B, C. And this is the crucial moment. I need to write this combination of letters in the proper way. If I start with A, on this triangle, which letter do I need to start with? C. Because A is equal to C. So C, okay? And then this D is going to be equal to B, right? So CBA. CBA. Okay? And the criteria, which criteria did I use here? SAS. Side, angle, side. The angle must be sandwiched between the two sides, which it is. Okay? Alright, guys? Alright, I'll just pause here for a second. Okay. So, once I know these two triangles are equal, there's another pair of angles that I know are going to be equal now. And these are these two. Okay? Therefore, angle A2 is going to be angle equal to angle C1. And what's the reason that I need to give? The congruency. Okay, so I basically just need to copy it. I know it's a bit annoying. Okay, so the true triangle, we just proved that they are congruent. So I need to rewrite that. I don't need to write the reason why. This is the reason. Okay. And once I know these two angles are equal, what does it tell me about these two sides? Parallel. That's it. So therefore, AB parallel to CD, and I need to give a reason for that. Okay? That's the converse of them being parallel. So I've got alternating angles equal. Okay? Because these are alternating angles, and I prove that they're equal, therefore these two lines are parallel. And now, because I know this is parallel to that, and I know that this one is parallel to that, I've got two pairs of parallel lines. Obviously, that's a parallelogram. Okay? So therefore, ADCB is a parallelogram. And that's the definition of a parallelogram, right? Two pairs of parallel lines. Alright, guys? Okay, I'll pause here. Okay. Guys, guys, what we're going to do now, we're going to solve one example. Okay, Ollie says he's not lying. It's not easy. It's not easy, but with a bit of practice, it is important. Now, I'm going to give you a tip. In my opinion, the most important tip for geometry. You need to start on some pages, maybe in a book, just purely for geometry, and you'll keep it from grade 10 to 11 to 12. And what you're going to do is write down all the theorems, all the new theorems, because the trick here, guys, is to remember the theorem by heart. You're not going to be given these theorems. If you remember these theorems, then you know how to solve the problems. If you don't remember the theorems, you're going to go around and around and around. You're going to spend so much time. Now, what we have right now is in page 169. If you look at page 169, you've got the parallelogram theorems. Theorem 1, the converse of 1, 2, the converse of 2, 3. There's no converse for it. Okay? If I were you, honestly, I would just write them on somewhere on a sheet of paper, put them separately, and before any test or exam that we have, you clean in, just stare at them and just make sure you remember them. Because right now they're just all scattered up, and every grade you're going to add and add and add to it. So yeah, that's my thought about that. Now, what you're told, this is exercise A. You've got this funny shape. You're told that A, B, C, D is a parallelogram, and A, B, D, E is also a parallelogram. And we want to show that E, B, C, F is a parallelogram. We want to show that the big one is a parallelogram. Okay? And we're told that BD equal to DF. It's actually extremely easy. If you're very confident with parallelogram. Check this out. If this is a parallelogram, let's look at the little one. Okay? Then I know that AB is equal to CD. Okay? Okay? Why is that? Because opposite sides equal in. And here I'm going to be a little bit. I'm just going to pause here for a second. Be sure. Okay, so we just need to mention why they're equal, because they're opposite side in the parallel. Okay? Now, at the same time, I know that AB is equal to, and this parallelogram, which one is it equal to? ED. And again, for the same reason, opposite side equal in the parallelogram. But then that means that ED equal to DC. Okay? And I also know that BD is equal to DF, that's just a given. And what does that tell us? It's a parallelogram because the diagonals bisect each other. So now I'm in a position to say, okay, EFCB is a parallelogram because the diagonals bisect each other. Okay? Now, if you don't remember that there is such a theorem, then you won't know how to do it. Okay? You could probably do it with alternating angles, start proving that we have similar congruent triangles, but it will take much longer. So the key here, as I told you in the beginning of this exercise, is to really, really memorize the theorems. Really, really memorize them. And the way to do it, in my opinion, is collect from each grade. Start, you're right, you got the table in that page that I told you, even before that, you have page 168. You've got stuff about quadrilaterals that you learned last year. Write it down, collect it, and then put it next to your wall, okay, if you're revising for tests, and just look at them every day for like 10 minutes, okay? I'll let you copy with that, and then the rest, guys, we just need to work through this exercise.